Hello, everybody. So the agenda of this talk is a brief introduction to insurance, and I'll be talking about AI and related technology. And then I will discuss 4 use cases, usage-based insurance, and then claim handling and insurance pricing. And finally, I'll conclude with a discussion of fraud detection, insurance fraud detection. So, so we all know what insurance is. It's officially, like formally, we can say it is a contractual agreement between an insurer and or insurance provider and insured, and the insured in this case will be a policyholder. Okay, so the insurer is obligated to compensate the policyholder for some unpredictable financial loss within a specific period of time. Okay, so a policy is this kind of agreement, and a premium is actually what we pay, like a monthly payment. That's the part of the contract, and the claim is in case of this loss. We as insurance, as insured, we apply for claims. And then sometimes there are deductibles, which is basically some amount of compensation that the insured pays, usually a minimum amount. So insurance is divided into 2 main categories: the life insurance, and then we have more a general insurance called property and casualty insurance. And property, this is more of house insurance, or like home insurance, car insurance, or auto insurance. This is what we call it property and casualty insurance. And the focus here is somewhat leaning towards the auto insurance. So the use cases will be more around that, but many of the ideas are actually applicable to other type of insurance. So to talk about artificial intelligence is an old discipline of computer science. It is as old as the theory of computability itself. So it started from the late 40s and 50s, and even Alan Turing, the father of computer science, has a test called Turing test for assessing a machine intelligence. Okay, so the word intelligence itself is a little bit broad in that sense. So machine learning is a subfield of artificial intelligence where the programmer to explicitly program the model. So what happens is the model, once it's been constructed, it learns from the data, and basically it may contain a lot of parameters that maybe needs to optimize some way. But what actually pushed artificial intelligence overall to higher level recently, and the booming of artificial intelligence, is primarily due to the advancement of deep learning. So deep learning is primarily a neural networks that has different architecture and different comes with different architecture and comes with different algorithms as well. And the main driving force behind neural networks and deep learning success is the abundance of data. So we're able to generate a lot of data recently, and beside that, the computational power, the increase in cloud computing, things like GPUs, and all these computational capabilities that actually help pushing the deep learning and become more and more successful field, solving very important problems in natural language processing and computer vision, robotics, and self-driving cars. So it's a very, very, very important progress being made recently. Okay, so insurance companies or insurance industry also try to benefit from this boom of artificial intelligence. People start using the data to make better decisions, to improve performance of business. So this graph is just shows the improvement in expenditure on artificial intelligence and data analysis from last year, June and August last year, to May this year. Okay, so we see that data analysis like last year it was around 50%. Now it's above 60%, and artificial intelligence spending is from 40% to almost 60% in just less than 1 year. So this is what insurance companies are investing in the field of artificial intelligence. And also the artificial intelligence, there are many related technologies, the big data analytics. We'll talk about cloud computing and talk about big data platforms like PySpark and Hadoop. And then the cloud computing itself as a new platform of pay-as-you-use the infrastructure, okay, and that make high computing power more accessible to small companies and startups, which is also driving the development of artificial intelligence. And we can talk also about Internet of Things. Internet of Things is a new technology where the normal devices like sensors and cameras and routers can be connected to the internet, okay, or to the cloud, and can gather data, live data. So that's a very important technology that help in improving, in generating a lot of data and improving the applications of artificial intelligence. There is also the blockchain, which is a new technology, a relatively new technology. Blocks of data that's immune to tampering, so to speak. So this way you can save data, insurance claims, for example, in a more secure manner. Okay, and AI and all these technologies can be used to improve how insurance is being approached. Okay, one of the use cases I'm going to talk about is usage-based insurance. It's more of an individual-based insurance rather than categories. Okay, so the principle of usage-based insurance is to pay as you drive, or pay as you you drive, or how you drive. Okay. So basically, if you are a good driver, a safe driver, that help you to get lower premiums, and that's definitely encourage safe driving. Okay, and for the insurer also, that help them to put better pricing models. So one of the techniques we're going to discuss later is how to, reduce the price for good drivers, for example, in this case, and attract more of good drivers. So you increase, you have a better competitive edge in the market. So one of the other benefits of this use case is the fraud detection and prevention. Okay, so so we have enough data, okay, gathered by the telematics, so that we don't really, we can easily detect fraud and misuse of insurance. Okay, and then also settling claims, we have enough data to make the claim settling more precise. So the data usually used in this case is use IoT data, for example. You can use sensors and GPS and cameras, even cell phones and other devices to gather data about the driving habit of an individual. And then based on that, you can collect this data and analyze it in a way that you can categorize different type of drivers, or different style of driving. Okay, so using maybe clustering techniques, or of course, I mean, when you collect this data, you can build maybe a map, a heat map of the driving and then you can process this data, okay, using techniques from dimensionality reductions like SVD, singular value decompositions, and autoencoders, and then you can do also clustering. So there's many ways of categorize how safe the driver style. The second use case is improve the claim handling, and claim handling is basically is the process of putting the data about the claim, processing this data, managing this data, and one of the main benefits or main advantage of that is basically you can have a better assessment of the claim, so you have an accurate claim payment, and that's definitely going to reduce also you can detect early signs of fraud, and overall it's more of an effective claim processing. So you can take the human out of the or the manual process out of the claim management, and try to make it more of an automated process. If you use data like the claim notes, okay, this is a textual data, and you need natural language processing techniques, natural language models, okay? And what I mean by natural language model is some sort of, and there is many ways to do that. the most recent one is the transfer learning. You can use also like a simple techniques. Bidirectional LSTM, also an option. So this is basically doing natural language processing in a claim nodes, and then use the output of that as a way of processing and managing your claim. Okay, so insurance pricing is a challenging problem. It's due to the challenge of assessing the customer risk. So if you increase your premiums, you lose customers, and if you have low premium, you decrease your profit. So it's the idea of how to manage that in a more of intelligent way. Okay, so people use a lot of data. I mean, the claim data, the policy information, geographic information, even background data, demographic data, and the most machine learning technique that have been used is the tree-based techniques like random forest and other boosting tree-based models. Okay, those have some advantage over the classical approach, which is general linear models. Because in the general linear models, usually there is independence assumption and for of the variables, and that's not really necessarily the case most of the time. So the tree-based techniques have some sort of edge over general linear models, which is a classical techniques that have been used in insurance. Okay, and then finally, I will conclude with the insurance fraud detection. So fraud is a big problem in insurance, and insurance company around the world uses a considerable percentage of their finances due to fraud claims. So that takes many forms. One of them is maybe if a customer submits forged application or forged documents, or stage an accident, or fabricate some sort of a theft, for example, to get the company to pay for the vehicle. Usually this data for fraud detection is very imbalanced data, because most of the claims are legitimate claims, not fraud so this imbalanced data falls into anomaly detection techniques, which is unsupervised machine learning. Some techniques you can use deep learning or a support vector machine as one class support vector machine as a way of detecting anomalies, and then if you have claim nodes, you can use LDA to generate features, and then use deep learning to detect the fraud or the illegitimate claims. So that's the last use case. This list of references discussing the same use cases I briefly talked about, and I'm happy to take any questions.
Thank you so much, Ashraf, for your presentation. We have One question here in the chat. What is the cost from Thomas Barco? What is the cost of getting the telemetry data versus the benefit of implementing the system?
Okay, I'm not sure I really understand the question, but the thematic data might be costly at the moment to implement to use because we don't have sensors in the car that produce such data. But in the future, there may be devices in the car that detect the movement, the driving style, and also the GPS data as well can be used. I'm not sure about the second part, comparing that to implementation in the system. I'm not sure I really understand what that means.
Okay, our time is over. If you have any questions and if you would like, you have two options now. You can go to the Talks channel and just continue the conversation and ask your questions directly to Ashraf, or you can also just meet together now and have a conversation. Ashraf, thank you so much for being with us and presenting at PyData Global 2021.
Thank you very much, and sorry for not being able to use my camera.
It's no worries at all. Thank you so much for being with us.
All right, thank you.